To the webinar room. Make yourself comfortable. We're going to wait just a few minutes to allow everyone the opportunity to join before we start today. And I am going to take advantage of that time while we wait for the stragglers to come on in and mention that we have a brand new private community platform called Thrive with Viome. And I'm going to pop it up here on our screen, which you can close that pop-up just by clicking that little close button underneath it. But that's a good little illustration for what I'm going to talk about. I want you to join us in the Thrive with Viome community. We're about 2,500 strong in there, people just like you, using your Viome recommendations to live healthier, eat healthier, and move forward on your health journeys. They're all sharing tips, supporting each other, creating healthy habits, getting support directly from our experts every week in there. Plus, we have fantastic live streams like the one this very afternoon, where I'll be live and we're going to talk about everything AI and show you how you can use tools like ChatGPT to be your co-pilot and help you on your health journey and do everything from create menus or recipes or meal prep, help you track and explore other healthy lifestyle habits to craft your personal healthy routine. I am Lisa Shomo. I'm head of community and live events host. I'm in there every single day chatting and supporting with everybody, and I invite you to join us. Just click on that link there and answer a few questions, and that's it. And with that, I think that's enough of a like vamp. I think we're ready to get started for sure. I'm just going to do one thing. I'm just going to close that for right now so we don't get any more pings. And I'm going to switch us to the next slide. And so we all know that when we say aging, we're essentially, meaning getting older, right? But what does that really mean for you and your body? Well, I happen to have the perfect person with me here today to show us exactly what that means. And I know you're all very excited to hear him talk, so I'm just going to let him do that. Viome's Chief Founding Science Officer and Head of Clinical Research, Dr. Momo Vuyisich. Excuse me, my lips got ahead of me. Dr. Momo Vuyisich. Welcome, Momo.
Thank you, Lisa. You're so nice. All right. Let's this featured action. I just need to remove it from my screen. There we go.
There you go.
Okay. Well, I am super excited, and it looks like we have people from all over the world, including Tamara Ristic from Serbia and people from South America and India and Australia. Absolutely amazing.
London, fantastic.
Amazing. Super exciting. I mean, wow. Okay, well, first of all, I want to say what time we live in where we have free access to unlimited knowledge. That's really, I think, the most exciting thing about today's world. Unfortunately, for many things, we need that knowledge because the chronic diseases are also on the rise. So that's not good, but at least the knowledge is there and we can exchange information and learn from each other. So I will share with you what I know and want to make sure that everyone understands microbiome science, human physiology, aging, all of that. Those are all very young sciences. We still have a lot to learn about the human body and how it functions and what controls everything and so on. But we're making really good progress and we have lots of science and technology. So we'll go over that. And so here's a summary of what we're going to go over today. I'm going to describe what aging is precisely in a very unbiased way, because that's what I want everyone to understand. We're going to talk about the language of microbes. How do microbes communicate with us? Because that's a very important aspect of the gut microbiome and oral microbiome that the vast majority of people will miss. And even in the scientific literature, this is missed. So we're going to highlight that. We're going to talk about the Viome's anti-aging program that includes the biological aging clock and how we compute that clock and what are the components, which is the microbial pathways. We're going to talk about microbial pathways, and I'm going to teach you a little bit of chemistry. It's a very simple thing that everyone can learn. And we're going to talk about a little bit about our recommendations, how they're computed from the data that we obtain for each person. We're going to talk about several examples of microbial metabolites, which I also call micropoop. This is basically what microbes produce in terms of chemical output. That's their poop. And how that micropoop can be very healthy for us, and it can be very harmful to us. And so we're going to go through several examples of very powerful microbial metabolites. Last but absolutely not least, we're going to get into like, what can you do today? Like right after this webinar, what can you do today to start your anti-aging journey? And we're going to end with, is it too late to start your anti-aging journey? What if you're 70 years old? What if you're 75? Is it too late? Should you just give up? So we'll get there. All right, part one, aging. So let's talk about aging as a huge risk factor for chronic diseases and cancers. What is plotted here is some CDC data. Elisa, can you see my cursor?
No, I cannot see your cursor.
Okay, then there's no point in me moving it around. So what you can see here is CDC data that show on the bottom of each graph what is the factor, and on the y-axis, or the height of the bar, shows what is the relative risk of death from that disease. And so what you can see here is that in all four graphs, aging is by far the biggest risk factor for cancer, heart disease, COVID-19, and Alzheimer's. Everyone talks about alcohol and smoking and obesity and high blood pressure and all these other things, but you can see that they pale in comparison to aging. So unfortunately, we can't say stop aging or don't age, and that's the trick, because that's inevitable, but we can age healthier, and that's really what we're going to discuss today. All right, so let's dive right into the molecules and pathways and super technical stuff, but this is really cool, and I will make some metaphors here that you can understand. So this is what human physiology looks like if you were to plot it on a piece of paper or show it on a screen like this. Human physiology is basically a concoction of about 100,000 chemical reactions. And these 100,000 chemical reactions power every single bodily function that you guys know about and that you don't know about. And so, for example, when you're chewing your food, that's a bunch of chemical reactions telling your jaw muscles to chew. When you swallow your food, that's more chemical reactions. When your body digests food in the stomach and intestines, that is many, many more chemical reactions. When nutrients are then translocated into the bloodstream, that's more chemical reactions. When those nutrients enter cells and are processed in order to build new cells, in order to generate energy, all of those are biochemical functions or chemical reactions. When your liver is chemically modifying toxins from the food and from the gut microbiome, those are chemical reactions. When your kidneys are clearing your bloodstream of unnecessary waste products, those are all chemical reactions. When your neurons are storing memories, when they're processing information, when visual signals are being processed, all of those are chemical reactions. So think of yourself not as a physical object, but as a vessel of 100,000 reactions. And when all of those reactions function perfectly at a perfect level, not too fast, not too slow, you have the perfect health. Absolutely everything works perfectly. Your digestion, your energy production, your muscles, your brain, your liver, your kidneys, all organs are functioning absolutely perfectly. 100,000 chemical reactions. When some of those chemical reactions start to not be optimal, so they're either too fast or too slow, that is when the aging process starts. And because we are operated by 100,000 reactions, if a few hundred of these reactions are too slow or too fast, you're not going to notice that. There's not going to be any symptoms. But when enough of these reactions fail in the liver or the kidney or the central nervous system or the heart or the any part of the body, now when enough of those reactions fail, now we can be presented with symptoms, and now we can be diagnosed with a disease. But the symptoms onset one day versus no symptoms the previous day doesn't mean that something dramatically happened overnight. It's just that enough reactions broke down such that one day you could notice the symptoms. But the day before, your body essentially had the same problems. And this goes way back years and decades. And so we now know, for example, that heart disease takes decades to set in. We know that heart attacks are preceded by decades of accumulation of plaques. We know that Alzheimer's disease is also decades old disease, and the symptoms don't show up until decades later. So think of this slide as a representation of the human physiology. That's one takeaway. It's about 100,000 reactions. And a big takeaway from that is that only about 50,000 of these reactions are actually powered by human genes. 50,000 reactions, or half, are powered by microbial genes. So think of your oral and gut microbiome not as you're tolerating some foreign enemy, but they're actually a part of us. We have co-evolved with them, and they're our best friends from birth. The very first thing that happens at birth, that is the most significant thing in life, is to acquire a healthy microbiome. And that goes on until you die. So half of the human physiology is human, half is microbial. Please remember that. Okay, now let's go a bit into, okay, how do we maintain health for a long time? And if you look at most other longevity programs and health span improvement programs, they are going to go for drugs. And to me, that simply should be a last resort, because nature has already figured out a way to maintain a very long health span with nothing but nutrition and lifestyle, nothing. So there are hundreds of thousands of people today living in their 90s, and they're mentally healthy, cognitively healthy, physically healthy, and immunologically healthy. And they have never taken an antibiotic in their life. They have never taken a pharmaceutical in their life. They've never seen a doctor in their life. So nature has already figured out how to keep us healthy for a very long time. So that's one major takeaway that I want you to know, that you don't need anything non-natural. And the second point I want to make in this slide is that think of your body as a 3D printout of the foods you have eaten. When a baby is born, literally that baby is a 3D printout of what mom ate during gestation. And as we grow, we are basically adding physical parts to our body. We grow based on the nutrition. These molecules don't come from outer space. They don't come from aliens. They don't just disappear. They're actually built based on the nutrients that we consumed. And those nutrients are processed by our own physiology and by the gut microbiome and incorporated into our body. So how you build up your body over the years and decades is what your body is how it's going to function. And that all comes from nutrition and lifestyle. So just remember that that's a big takeaway. It's going to get a little technical here, so I'm going to go a little bit faster, but happy to answer any questions later. So what is Viome's approach to anti-aging? So we discussed that about 100,000 chemical reactions power our physiology. At the current time, Viome measures about 24,000 of those biochemical reactions. And those are then converted into an aging model or aging clock. And you can see the graph on the right, identify aging biomarkers. We have identified 1,271 chemical reactions out of 24,000 that we measure that are very strongly predictive of how fast someone is aging. Are they aging more slowly or more accelerated? And I will go into a little bit more detail into those 1,271 reactions in the next few slides. But then when we profile our customers' stool, blood, and saliva samples, we actually quantify the level of those reactions. And you can see on the bottom left graph that we assign quantity to each one of those. And 0 means just the right amount, healthy. But you can see on the left side of that graph that some reactions are accelerated, which is not good. And on the right side, you can see that some reactions are slowed down, which is not good. And those are the ones that we need to address with nutrition. Now, how do we address chemical reactions with nutrition? I will actually go into that in the next couple of slides, but I just want to mention here in the bottom right panel that we can actually modulate those biochemical reactions using micronutrients in your food. So that's sort of the anti-aging program cycle at Viome. We measure a lot of relevant biomarkers. We've identified using machine learning 1,271 of them that are very relevant and predictive of aging rate. For each person, we profile those 1,271 and quantify which ones are accelerated, so that's not good, which ones are too slow, which is not good. And then our Viome recommendation engine recommends how to slow down the ones that are too fast and how to accelerate those that are too slow. All right. So just wanted to throw out a slide as to if you're wondering, okay, what are those 24,000 biomarkers? Here they are. So these are the normal 3 samples that we would receive from a customer: stool on the left, saliva in the middle, and blood on the right. And then you can see in the table that I listed the number of each type of these biomarkers. And here's a slide just to show how we developed this machine learned model. It was on a very large data set, so we used about 20,000 samples for training the machine learned models, and then we validated it on close to 9,000 samples. We published this in iScience. The publication is listed on the slide, so you guys can geek out and go check it out. Here we're diving a little bit more deeply into the 1,271 biomarkers of aging that are included in our aging model, and I've broken them down by which sample type they come from. So we have 374 of them in stool, 452 in saliva, interesting, right? And 445 of them in blood. And I just listed some of those, and you can see that some very well-known things like glutathione production, vitamin B12 production, butyrate production, GABA production, ammonia production, all of those are very important parts of our physiology, and those are all scores in the Viome app that you can see: protein fermentation. And then in saliva, I highlighted nitrite production. If you're interested in following that thread, it's a very important thread. Nitrite production in saliva by the oral microbiome contributes heavily to regulation of our blood pressure, especially as we age. And so that's a very important chemical reaction. And then I listed some of them in blood that are as well very important for aging. So the graph on the right is just a super geeky way of showing what kind of data outputs we obtain from these very large data sets. One more thing I want to mention from this paper that we published is we looked at populations of people who self-reported as vegetarians, vegans, paleo following, and ketogenic following. And what we're plotting on this graph is how fast they're aging. If they're aging at 0, that means they're exactly the same as their chronological age. People who are on the left are actually aging more slowly. So their biological clock is lower than their chronological age. And graphs on the right are there, those people have accelerated aging. And so what you can see here is that vegetarians and vegans, on average, have slowed down their aging process, whereas people who are following paleo and ketogenic diet have accelerated their aging process. These are associative data. We have not run randomized controlled trials, so this needs to be verified in a larger cohort that's prospective and so on. But this is very strong evidence, because of the p-values are very strong and the n's are very high, that these diets do affect our aging process. Okay, let's now explain these pathways, these magical things. So I told you earlier that I think that our body is powered by about 100,000 chemical reactions, and you can combine a few chemical reactions into one pathway. So a pathway is simply a combination of several chemical reactions that are all in line to each other, that go from a micronutrient in food to some metabolite. And we're going to be talking about several very important metabolites, but let's now figure out how microbes make those metabolites. So I'm going to go with something that you all know, which is, here's a chemistry. This is like chemistry 101 in college. What is a chemical reaction? A chemical reaction converts chemical A, or substrate, into chemical B, or product. So think of chemical A as some ingredient in a food you're consuming, and think of chemical B as butyrate, LPS, ammonia, all of those metabolites that the gut microbiome and oral microbiome produce. And in between is this chemical reaction, or typically multiple chemical reactions that we call pathways. Okay, so now let's talk about the real life example. We're going to make some beer here. So you guys know that the way to make beer is you have to provide barley and brewer's yeast. And if you do that, you will get beer. So how does that work? Barley is first chemically converted into simpler sugars, and this is called malting. So if you're not familiar with beer brewing, that's called malting, where enzymes are used either native to barley or they're added externally to break down the polysaccharides from barley into simpler sugars. And now you add brewer's yeast. And that brewer's yeast, you can see here in the box, is using several enzymes to create one pathway where brewer's yeast converts sugar into alcohol or ethanol. And why is it doing that? Why is it converting sugar into ethanol? It's eating. That's what brewers. So microbes don't chew their food. They don't do what we do. They basically grab these nutrients from their environment, such as sugars, and they use enzymes, just like I showed above, to process that sugar into ethanol. And during that process, they harvest energy from those chemical reactions. And that's what enables them to live. That's basically it. And so these microbes, nutritional ingredients in our food, we are feeding them to live their own life. And during that process, they're making these chemicals that we call metabolites, such as ethanol in this particular case. And we're going to go through about 6 or 7 examples of these metabolites that have an impact on our health. And you guys probably know that ethanol already has an impact on our health. It's a negative impact. Any amount of ethanol is bad for you, and that's because it's a toxin. And so let's go to the next slide now. So I mentioned in the summary slide that we're going to talk about chemical communication. So we discussed how 50,000 or half of the chemical reactions that power our physiology are from the microbes, and half of them are from the human side. They communicate using chemical signals. They do not have a language like words. They literally have chemical signals that they're passing to each other, and that's how they're establishing a healthy physiology or an ill physiology. And again, we're going to talk about these chemical signals with about 6 different examples. And I just want to show you here a couple of more examples that are actually relevant to our physiology and relevant to our gut microbiome. So the top side of the slide is showing that when you eat cruciferous vegetables, so that's your broccoli, your cauliflower, your Brussels sprouts, there's a compound there called sulforaphane, and that is the substrate for chemical reactions for specific microbes that can convert that sulforaphane into hydrogen sulfide gas. And during that process, the microbes will harvest energy, and that's what they live off of. Now, it turns out that we have co-evolved with microbes to depend on this hydrogen sulfide gas to actually power our gut motility. And we will dive very deep into that area in one of the slides. On the bottom part, I'm showing that when you consume an apple has this polysaccharide called pectin. Some microbes in your microbiome, or maybe another person's microbiome, will process that pectin as a substrate into butyrate, and the host will benefit from that. And so those are the pathways that Viome's tests quantify. So now let's dive into these metabolites. Lisa, how's it going so far? Okay, you're muted, sorry.
Yes, great. We're having lots of activity in the chat, and I already have a couple of questions marked for later on if we have more time. No rush, but some pretty cool questions.
We will have time for questions.
Thank you.
All right, so let's talk about these microbial metabolites. So we already went over some of them. I showed you how brewer's yeast makes ethanol, showed you how some microbes make hydrogen sulfide, and showed you how some microbes make butyrate. Let's dive deeper. So here's the first one that most people, including most scientists, are not familiar with. This one is called phenylacetylglutamine, and it's a microbial metabolite. This part here, phenylacetyl, is necessarily made by gut microbes. We are unable to make it, but we add this glutamine, human gene. So this is where, in order to make this metabolite, the microbes in our body and our own genes have to work together to produce it. And once it's produced, it's one of the most important contributors to cardiovascular disease. And this has now been shown in several very high profile, very strong publications. And I have listed those publications here. Lisa, will you be sharing the slide? Oh, well, this will be shared online, so you can always go back to this video and look at these publications. And so this PAG has been shown to accelerate aging by these mechanisms, and it's associated strongly with multiple sclerosis. Is it causative of multiple sclerosis? We don't know yet, but it damages neurons directly. And so it's possible that it's actually causing at least some versions of multiple sclerosis. Let's go to so one thing I want to mention is that PAG is made from proteins that we consume. In other words, the more protein we consume, if you have the right bacteria and they're not distracted by other substrates, they're going to be making phenylacetyl, which will then enter the bloodstream, and our body will finish it up by adding glutamine. So we will make phenylacetylglutamine. And so the necessary substrate for making this is dietary protein intake. So if you're taking too much protein, which is just the biggest buzz these days, which is a fad and it'll go away, but that's okay. Don't follow the buzz and don't consume too much protein, especially not animal protein, because your microbes can make this very damaging compound or a metabolite. Now let's get into trimethylamine. So TMA. TMA, or trimethylamine, I'm showing the structure here, is produced from several dietary sources. These are choline-rich foods, and they're both animal and plant sources. Red meats and animal livers are the highest concentration, but dairy, eggs, soybean products, and a canola oil have these choline-rich foods. And then carnitine-rich foods are only found in animal products, especially beef and lamb. And so when you consume these foods, if you have the right microbiome, and that microbiome is not distracted by other nutrients, they will make trimethylamine. And trimethylamine is the longest established causative agent of atherosclerosis and cardiovascular disease. And again here, just like in the previous example, the actual metabolite that causes cardiovascular disease is called trimethylamine oxide. And in order to make that, we need both microbial functions and human functions. So TMA, trimethylamine, is made by the gut microbiome. The oxide part is added by our own liver, and that's made into TMAO, which is very damaging to our health. So here again, when I mentioned previously that half of the chemical reactions in our body are human, half are microbial, here are two examples where they work together hand in hand. Whoa, let's dive deeper. So this is what we work with every single day at Viome. I look at these metabolic maps every single day. Our computational systems biology team, this is their job. This is what they do every day, interpreting the data that we have in order to make highly precise nutritional recommendations. So I'm going to quickly go over this because I could talk about this slide for an hour in sort of geeky scientific terms, but let me just give you a summary. This slide is about hydrogen sulfide production in the colon. Hydrogen sulfide is one of several factors that determines our bowel movements. Too little hydrogen sulfide, and we are likely to be constipated. Normal amount of hydrogen sulfide, and we're likely to be regular. Too much hydrogen sulfide, and we're likely to have diarrhea. So it's directly proportional to our bowel movements. And you want to have just the right amount. And so how is hydrogen sulfide produced in the colon? It's produced by microbes. Humans can also make some of it, so leave that aside for now. But the major source of hydrogen sulfide comes from our microbes, and they can make it from several molecular sources. One of those is from our own bile acid. So taurine is a bile acid component that contains sulfur. All others are nutritional. So here we have sulfates, we have glucosinolates from cruciferous vegetables, and then we have methionine and cysteine for protein sources. And so there are about 80 total chemical reactions here taking place in nature. And it turns out that in Viome's data, we can quantify 60 of those 80. The other 20 we have not observed yet in the gut microbiome, which means they're likely environmental. They are in the environmental microbes that do not populate the human body. So those 60 that we can quantify, we can precisely tell in each person how is sulfide made, from which sources, and we can tell how much sulfide is made. And so we have a hydrogen sulfide score that tells each person how much sulfide is made. And here's how we can use our data to actually make very precise dietary recommendations. So in one person, for example, if taurine is the major source of sulfur for sulfide and there's too much sulfide production, we can then say that we need to lower our fat intake because fat intake stimulates taurine release into the intestines. If there's too much production of sulfide from either cysteine or methionine, we can modify our protein intake, and we can actually modify it based on what the ratio is of cysteine and methionine sourcing for sulfide, because cysteine, for example, is found in chicken more than in any other source, plant or animal, whereas methionine is found 2.5 times more abundant in all animal protein relative to plant protein. So if you need more methionine, you could eat more animal protein. If you need less methionine, you would shift to plant protein. If you need less cysteine, you would want to remove chicken from your diet. And if you need more cysteine, you would want to eat chicken in your diet, or you eat more of other protein. And finally, glucosinolates are found in these cruciferous vegetables. They're also called brassicas. And if that's the source of sulfur, you can modulate how much cruciferous vegetables you eat. If you need more, you eat more. If you need less, you eat less. So this is how we can modulate all of those 100,000 chemical reactions in our body using nutritional ingredients and some other nutritional advice. Okay, let's go on to butyrate. So we talked about microbes making butyrate from pectin. Butyrate can be made from many different sources, but mostly from undigestible polysaccharides, what we call fibers or prebiotics. And butyrate is sort of the most famous metabolite that the gut microbiome makes. It is healthy in so many different ways. We could discuss that in a full hour, but I'm just listing some of them here and showing some data here that it is super important in colonic health, intestinal health. It's super important in immune health, in autoimmune diseases, and so on. And I will show you one example that I find completely fascinating. So you guys know already that if you vaccinate 100 people, not all of them will be protected. You also know that if 100 people get a disease such as COVID, not all of them will be protected from other COVID viruses. So why is it that some people remember, their immune system remembers the infection and protects you from future infections, and in some people, the memory is lost? And we have now teased apart the exact mechanism of this. And when I say we, I mean the scientific community. We have not solved this problem at Viome. This was published by some reputable scientific groups. And what you can see here is, I am in the upper left. What it's showing is that a specific fiber has to be consumed by that person. That person's microbiome, it says there, bacteria in the colon. The bacteria in the colon of that person will consume that fiber. They will put out a final metabolite, which is butyrate, down at the bottom on the left side. And then that butyrate will enter the bloodstream and it will signal our immune system. That's the chemical language of the microbiome and human physiology. The butyrate will signal our T cells that are responding to an infection or to a vaccination to become memory T cells. So they will literally transform themselves into memory T cells, which do not die. They stay with you for decades or for the rest of your life. And so if that mechanism is broken, meaning at the time when you're vaccinated, 2 weeks following a vaccination and 2 weeks following an infection, if you're not consuming the right types of fiber for you and your microbiome is not producing butyrate, the immune response, the cells responsible for killing the virus at that time, will all die, and you will no longer remember that infection. So next time you get exposed to that virus, you will unfortunately get sick again. So this is one of thousands of ways in which microbes and human physiology have co-evolved to depend on each other. Now, one question that I get asked often is, well, in case your microbiome is not producing butyrate, can you supplement it? And I don't know with a solid statistics that is sufficient enough, because it may not be sufficient enough. There are papers showing that does not have the same physiologic effect as butyrate that is produced in the colon, but it cannot hurt you. And so if you're worried about, if you have a compromised gut microbiome and you just got vaccinated or you're experiencing an infection, I can't see harm in consuming butyrate. So yeah, that's a pretty safe thing to do. Let's talk about a couple of more things. So this one is lipopolysaccharide, or LPS. This is a very well-known activator of our immune system, meaning that if enough is produced, it will kill you. And if small amounts are produced, it will simply cause chronic systemic inflammation, which is likely one of the main root causes of many chronic diseases and cancers. And so this lipopolysaccharide, again, it's a molecule produced by microbes, by specific bacteria, gram-negative bacteria, in response to being fed. And I have written some notes here with a little more details, but we can't go into such details at this level. But you guys can read about this a lot. There's a lot of information. ChatGPT can provide you with information. Speaking of ChatGPT, sometimes it gives wrong information and sometimes it gives the opposite information. So you cannot take everything. So ChatGPT is a great sort of a first screen, like to give you ideas. Once you get those ideas, verify them using Google searches and credible scientific literature in PubMed. That's what I do every single day. I don't trust ChatGPT with any scientific information. It's great for giving me ideas, but not for giving me the ultimate answer. So LPS production is something that Viome has been carefully trying to modulate since day one. We have known about LPS. We know that it's an important metabolite. And our anti-inflammatory program since day one has been to reduce the production of LPS because it can cause a leaky gut, it can cause a leaky blood-brain barrier, it can activate the immune system, and it's probably the root cause of most chronic diseases. I think this is the last one. Yes, last but not least, if you haven't heard of this one, it's an interesting one. It's called urolithin A. This is sort of a more well-known metabolite of microbiome, but more recently, like in the last few years. So when you consume certain polyphenols that are found in plants, these are ellagic acid and ellagitannins. Your microbiome, and that is the case with about half the people, will produce this molecule called urolithin A. So just like we discussed before, specific microbes can produce specific pathways that we can quantify at Viome that convert polyphenols into this urolithin A. And this urolithin A is like a magical thing. It's just got a slew of very, very beneficial effects on our physiology, including, I've listed here on the right side from this paper, a whole bunch of antioxidant, anti-inflammatory, muscle protein synthesis. I mean, there are several randomized controlled trials where people exercise in a resistance training model, and people who are on urolithin A actually gain more muscle mass. Nothing else, no other difference. Now, there are two ways to obtain urolithin A. One is you eat pomegranate peel extract, which you can buy anywhere. Note that that is not pomegranate juice. Pomegranate juice has very little ellagic acid and ellagitannins. It does have some, but very little. So you need to get the peel extract, which is available. Berries, several berries have lots of this polyphenol. And then walnuts and pecans also have this polyphenol. And so if you consume those foods, and if your microbiome is converting those polyphenols into urolithin A, boom, you have a benefit. And that's basically free, except you have to pay for food. There is urolithin A as a supplement, but to my knowledge, it's the most expensive supplement on the market. So I don't use that route. Okay, wow, we're done with metabolites. And so let's just spend the next 5 minutes or so on what can you do today, and are you tooled to start this anti-aging journey? And then we'll open it up to questions.
Okay.
So this slide here is basically, we can go over it in a full hour, but what it's saying, what is the takeaway here, is that your health is determined by many factors. And I've listed most of them here, but there are others. And so it's not like whenever someone says your genetics is the reason for your health, that's not true. If someone says your gut microbiome is screwed up and that's why you're not healthy, that's probably not true. If your immune system is screwed up, you're not healthy. That's not true. All of these factors likely contribute to most chronic diseases. The truly genetic diseases are rare. The truly diseases that are caused by one thing, like heavy metals or mycotoxins, are rare. You need additional factors like genetic predisposition, certain microbiomes, certain other nutrients, and so on. So think of yourself as 100,000 reactions and think of so many different factors affecting those 100,000 reactions. And so let's dive into what I practice every single day and what I think everyone can and should practice every single day. And these are going to be sort of small things that you can do that I think have a very large contribution to our health. So my 4 pillars of health that I practice every day, I'm not including smoking here, because smoking, if you're smoking, just cut it out and you're done for life. If you're drinking, cut it out and you're done for life. Those kinds of things are not like a daily routine. That's like one-time deal. Just get rid of them. But here's the daily routine. Nutrition. If you go with Viome Nutrition, you will get all the advice you need. But even if you don't go with Viome Nutrition, there are some general things. Don't eat fast food. Don't eat fried food. Don't eat food that has chemicals. Don't eat food that has antibiotics, and so on. So eat a rainbow of vegetables every single day. Reduce meat and dairy and eat more plants. Your carbohydrates should not be processed. They should be whole wheat, whole oats, and so on. Those are sort of general things every single meal follow. If I am unable to follow this, I will skip a meal. Like if I'm in an environment where I either have a choice of eating a bad meal or I'm going to be hungry, I easily choose to just stay hungry. I'm not going to introduce bad nutrients into my body, because remember, we're 3D printing our body for nutrients. So if you introduce bad nutrients, you're going to 3D print bad parts of your body. So why would you do that to your body? Hunger is nothing to be afraid of. In fact, for a lot of people, fasting is healthy. So there's no danger in skipping a meal. When it comes to exercise, again, we could cover this topic in a full hour, just exercise. But the bottom line is, it has been shown in very, very large studies that an hour and a half of weekly combined cardio exercise, whether that's zone 2 or HIIT training, whatever you want, just don't worry about all the details and maximizing. Do an hour and a half of combined weekly cardio, and then do an hour and a half of weekly strength exercise or resistance training. And that's the best you can do for your body. It doesn't matter if you're doing weights or cables. It doesn't matter if you're like doing this many reps and this many, like all those details, fine. If you want to geek out, if you want to maximize things, if you want to like get into like the maximum performance returns, yeah, go watch 1,000 YouTube videos and go do it all. But just do something for an hour and a half for cardio and an hour and a half for strength training. That's it per week. And you're done. You're like most of the way there. Sleep, don't underestimate this. Apparently, Americans are chronically sleep deprived, and apparently that's becoming more popular even outside of the United States. You got to get 7 to 8 hours of sleep every single night. If you don't, it doesn't matter what your nutrition and exercise and Zen are. You're not going to do well in your life. Last, but I would say not least, is Zen. And Zen is a Japanese term, but many, many other countries have different terms. Zen just means peacefulness of mind, meaning low stress, meaning enjoying life, meaning displaying gratitude, practicing gratitude and practicing meditation, and just appreciating the moment. So again, I can spend an hour just on Zen, but we don't have time for that. So read about that. If you're in a stressful situation, either at work or at home or both, it doesn't matter what your nutrition, exercise, and sleep are. Your body is going to be so badly affected by that stress that you cannot get healthy. And so focus on these 4 every single day. And if you're unable to achieve the Zen state, you might need to fundamentally rethink your entire life. Like, I need to move out of here, or I need to hang out with different people, because this is very, very important. Okay. Again, I have a slide on this that you guys can read about. Again, I can spend an hour in each of these topics easily, but we don't have time. And last but not least, am I too old to start the longevity journey? So there's this myth out there in the interwebs and so on that once you turn 50, boom, you're starting to decay and you're going downhill and life is over. That is absolutely not true. That has been scientifically proven to be wrong. People in their 70s and 80s can not only cognitively improve, they can also actually increase their muscle strength and their lean body mass, so muscle mass, with the proper nutrition and exercise. So I would say, unless you're like 98 years old and frail, okay, that's a sort of an extreme thing. But if you're in your 50s, 60s, and 70s, you can absolutely start your anti-aging journey, and you can improve your cognition, you can improve your physical strength, you can improve your muscle mass, and prepare yourself for even older age. So that's that for today.
It is. And I want to tell you that Susan in our chat said, I'm 76 and Viome is helping. So she's on the bandwagon. She's getting it done. She's doing it.
Absolutely. Absolutely. No doubt about it. I'm 52 and I'm the strongest I've ever been in my life just because I started strength training 2 years ago.
Nice.
And I've added muscle and strength like crazy. And that's just unbelievable based on, reading the interwebs. So yeah, start your journey today.
Absolutely. We do have a few questions here that I found pretty interesting. Let's see. Michael said, how can it be explained that when someone who has lived on a clean vegan diet experiences early onset cognitive decline and neurodegeneration? What could have happened? What went wrong? You have some thoughts on this, yeah?
Yeah, of course I have thoughts on that. Yeah. So, I mean, that there are many factors that affect our cognition. So first of all, if you're vegan, it does not mean at all that you're healthy at all. And there are two major reasons for that. One is that some of the foods that you're consuming may be toxic to you. And so unless you do a microbiome test like Viome and a food sensitivity test from some other company, and potentially mycotoxin tests and so on, you don't know that you're eating healthy. So vegan is not the healthiest diet for everyone. That's one thing. The second thing is, today, plants are not the same plants that we had 30 years ago. So when you look at the nutritional profile of plants 30 years ago, they had healthy soil that was absolutely filled with all kinds of chemical elements, all kinds of chemical compounds, organic matter, very diverse microbial community. Industrial farming has killed that. And so now plants basically are getting just the absolute minimum number of nutrients to grow and to look like a plant, but do not assume that they're nutrient rich like they used to be. And so for that reason, I take about 100 supplements every day, not 100 capsules. I take about 25 capsules every day, but they contain 100 different chemicals, even though we are mostly vegan in my family, because I cannot count that the plants have what they used to have. And so we have to supplement. Yeah. And so I would highly encourage people to research, and maybe Lisa, we can have like a supplement webinar where we talk about what are the most critical ones that are likely missing from the diet, no matter what you're consuming. And then we can dive into, like, if you're a vegan, what you might be missing and so on.
That's a great topic. Absolutely.
Another thing is that fungi, known as molds, are a huge contributor to brain fog and cognitive decline, huge. And so this is sort of a medical frontier that the classic medical community has not addressed. And I can spend an hour talking about molds and fungi and why we have not made huge progress. But at Viome, we have the best fungal database in the world, and we have developed some machine learned algorithms that show that molds are very likely responsible for a large fraction of cognitive decline. And so how do you learn about that? So go out and learn about those resources online. Second, do a mold test. There's a test that I like, which is a real-time labs urine test that I like. No test is perfect. Yes, true. But go do it and see what it tells you. And then inspect your home and maybe even test it and see if you might have a mold problem, because that can cause cognitive decline. Heavy metals can cause cognitive decline. So go get yourself tested. There's no downside except some money to go get tested for mercury or arsenic or so on poisoning. So do that. So yeah, there are many reasons. Exercise, for example, is lack of exercise is a huge risk factor for cognitive decline. We talked about LPS. LPS is very well known to make the blood-brain barrier permeable, which means now that the immune system components and chemical toxins can enter the central nervous system and affect your central nervous system the way they're not supposed to. And so just LPS production, too much of it, can cause that. So there are many factors. So the only way to know these things is to get tested. Otherwise, you're guessing, and you don't know which factors contributed to your own cognitive decline.
Absolutely. Absolutely. So speaking of supplements, and apologies if I am pronouncing their name incorrectly, Meta, some genetic unlucky people cannot methylate B12, magnesium, folic acid. So is there a way to create, I think, modulate your microbiome to compensate for that? What do you think about that question?
Yeah, I'm not an expert in that field, so I'm simply not going to answer that question because I don't know. I have read some things, but I don't have enough knowledge to know. We do include some methylation supplements in our algorithms, and so that may be helpful, but I would encourage everyone to go, again, do the first screen with ChatGPT, go visit some Reddit forums and other forums, chew on that information, read some scientific literature if you can. There are now AI engines that will digest a scientific paper and give you sort of a summary. You cannot trust it 100%, unfortunately, but there are resources, but I'm not an expert to answer that question. I apologize.
Okay. Fair enough. Fair enough. Here's one more question. I think I have two more. Brett says, I wonder how a diet of moderation, good mixture of meats with fruits, vegetables, and grains would influence life expectancy compared to the other diets that Momo showed. And I mean, of course, we do have a point of view on this, but that's a great place to start, wouldn't you say?
Yeah, that's fine. But I think everything in moderation, it sounds good, but I think it's going to be good for maybe 50% of the people, but that diet for 50% or more people will contain things that are harmful to you. And so moderating is kind of a safe thing, but it doesn't at all mean that you're going to do well. You have to get tested and know exactly what's happening. So yeah, that's the reality of it. We are all different, and we simply have to do the tests in order to see what's going on inside our body.
Exactly, exactly. So one more, this gets pretty specific for Diana, but she said, can you explain a bit more about the amount of protein you eat, especially she's postmenopausal. She was a vegetarian for 30 years. You are vegan, I believe, vegan. And it, Momo, and it felt that my body needed more meat since I entered menopause. The recommended intake is about 1 gram per body weight. That's hard to do. I did the Viome test, and it said to avoid whey protein, cottage cheese, and milk, which were my main protein sources. Since eating too much meat is not healthy, what do you think is a good balance?
Again, this is a highly personalized topic. A generic answer that, if you're not going to do any testing, a generic answer for me would be get a total of 75 grams of protein. If you're like a 150 to 200 pound person, let's say, get 75 grams of total protein, but it has to be divvied up into 3 meals. You should not consume 75 grams of protein in one meal. Divvy it up into 3 meals with 25 grams of protein each, and make as much of that protein from plant sources as you can. So on average, an average human is going to be just fine with that amount. That's in fact sort of super safe amount. Like for an average human, you're not going to need more. Exceptions would be for people who are trying to rapidly increase their lean body mass. So I am trying to increase my lean body mass, but I'm not trying to do it rapidly. So I still follow the same 75 grams per day rule. But there, if I wanted to increase it by 10 or 20%, I could double that protein. But that comes with such health risks, especially from animal protein, that it's not worth it. And if you try to consume twice as much as protein as I am taking from plant sources, unfortunately, plant sources in general are more calorically heavy. That means that you would need to consume so many calories that you're either going to have to do a lot of cardio per day, which I don't have time for, or you're going to gain weight. None of those are good. So protein moderation is very important. And I would say in general, 75 grams split into 3, but follow your Viome recommendations for protein fermentation, because we can quantify in your colon how much excess protein made it into the colon, and it's causing production of these bad metabolites.
Okay. So there's some advice for you, Diane. If you need more advice, I would definitely lean on your doctor to see how they can help you out with recommendations of that, along with your Viome recommendations. And speaking of testing, I want to pop this up because Natalie just asked me, what test should I start with? I do recommend, and I believe that Momo would too, to start with your full body intelligence test, because that gives you the biggest picture of what's happening with your body right now and gives you food and supplement recommendations. And I have that link right there. If you use that link, it will take you to the Viome website and attach a handy code, MOMO, that gives you $100 off this full body intelligence test so you can get started or retest and continue with your health journey today. So Momo, do you have any last words?
Yeah, let me address this question because
absolutely.
So testing is such a big deal because it really can be a financial burden. And so let's not ignore the fact that not everyone has $3,000 to spend on tests, right? And so I would say if you have no money on tests, you can do a lot of these generic things that will work for some number of people, and they may work for you or not. So that's the first step, and do those 4 pillars of health. Second thing, if you have some money, not a lot of money, but some money, then the question is, what test is the best?
Yeah.
And that'll depend on how much money you have or you want to spend, and it'll depend on your symptoms. And so that's the next step. And that I will answer that question when I answer the last question, which is, if you're like, hey, my health is very important to me, I want to pay, I'm fine to pay $1,000 or $2,000 today because it may prevent me spending tens of thousands of dollars later on some chronic condition. I would say the sort of the minimum set that everyone should do is the full body intelligence, like you said, from Viome. I would do a 96 food sensitivity test from Everlywell. I would do the mycotoxin urine test from Real Time Labs. I would do a full metabolic and lipid panel from your doctor, which is covered by insurance. So this is your fasting insulin, fasting glucose, your lipid panel. Don't forget ApoB and LP(a). Don't forget those, because those are not normally included. And even fasting insulin is not normally included. So go ahead and do that. And then I would definitely do hormones. So hormone testing, if you're a female, do the female hormones. If you're a male, do the male hormones. And I would even go out and get a heavy metal test just in case. And those are going to point out any sort of things that you need to think about. And so Viome tests will show you, what are the foods to avoid? What are the foods to maximize? What are the foods to eat? Supplements that you need, and so on. The food sensitivity will give you the sort of precise reactions that your immune system has to specific foods that you should just avoid for a while. Obviously, if you have mycotoxins in your urine, you should really look into your environment, whether it's at home or at work, and try to figure out where is that coming from. And it's possible that the mold has colonized you. So that's where you need to really beef up your microbiome by rewilding it. And Lisa, do you have the ability to provide links later on to the webinar attendees?
Yeah, sure. Absolutely.
Okay, so I will share with Lisa some links to how to rewild your microbiome.
Oh, that's great. Yeah.
What are the tests that I recommend, and so on.
Great. I will send that to everybody who's in attendance right now.
Great. So those are the things that that are all available today. They're even available direct to consumer. And so if you're able to do if you're able to spend some money, go out and learn about your body. Another test that I highly recommend that's unfortunately very expensive is the GRAIL test. The GRAIL test costs $1,000, but it detects the presence of 1 of 46 cancers. And so, if you're 30 years old, of course you shouldn't do it, because the likelihood of you having cancer is extremely low unless you've got tons of money. But if you're in your 50s, you may consider doing it every year or every other year, and so on.
All right. Yay. So I'm going to get that information from Momo. I'm going to send it out to everybody who's here attending today. I will get the deck to the people who requested it as well. And thank you, Momo, for spending time with our audience today and giving them all this valuable information. You can see they suck it up. They love it. They just love it. And I really appreciate you too spending the time to do this with us. And I can't wait to have you back again very soon.
Awesome. Thank you, everyone, for your audience. Have a good day.
All right. Thank you very much. Everybody have a wonderful rest of your day. Bye-bye.